This is the lecture for lesson 9. The first part of this lecture is going to be talking about slopes, how we find and calculate slope, as well as x and y intercepts. First equation we will talk about here is the slope of a line. The slope of the line, represented by m, is the change in y over the change in x. Given 2 points, x1, y1, and x2, y2, we can use the following formula to determine the slope between these 2 points. M equals y2 minus y1 over x2 minus x1. So that's the first thing we're going to work with here. We're going to talk about how we find the slope, be it up from left to right for a positive slope, or down from left to right to be a negative slope. First thing I'm going to do is label my points. So I have 3, 1, so x1, y1. And 5, 4 is x2, y2. Now, we do also technically have 2 other slopes. We have a horizontal line, which is going to have a slope of 0. There is no slant to my line at all. So remember, I always go left to right. So this first one, if I'm going from left to right, is going up. Left to right is going down, negative. This one is flat, so it's going to be 0. And then the last one is a vertical line. And unless you are Spider-Man, there is absolutely no way that you can walk up this wall or a vertical line. It's impossible unless you have equipment and you're a rock climber or you're Spider-Man. Okay, so this one here is what we call undefined slope. So when you read the directions here, find the slope of the line passing through each pair of points, or state that the slope is undefined. So if we ever end up with a vertical line, know that we have an undefined slope. Otherwise, we'll be able to get an actual answer here. So we labeled our x1, y1, x2, y2, and now I'm just going to go into my formula. So y2, 4 minus y1 is 1. x2 is 5 minus x1, which is 3. Well, 4 minus 1 is 3. 5 minus 3 is 2. So 3 over 2 is my slope. Next one, negative 3, negative 2. That's my x1 and y1. And then 2, 5 is my x2, y2. So following the formula, y2 is 5 minus y1, negative 2. All over x2 is 2 minus x1, negative 3. When you subtract a negative, that turns to plus. So 5 plus 2 is 7. 2 minus a negative makes 2 plus 3, or 5. So 7 over 5 is my slope. I want you to realize that if I were to calculate and end up with 0 over 7, I can do that. That is going to be the 0 slope. If when you're calculating your slope, you get something like 10 over 0, and you try to type that in a calculator, 10 divided by 0 is going to give you an error. It cannot be done. So it is the undefined because it is forming a vertical line. Based on these images here, this next question should be pretty easy. If a line rises from left to right, what kind of slope does it have? Well, the one that's going up is this first one here, and that is positive, or if you want to actually write the word out, positive. The basic form that we are going to look at with lines is called the slope-intercept form. And it is going to contain exactly what it says. It's going to have the slope, and it's going to have the y-intercept. This form is y equals mx plus b. M, we already know, is the slope, and b is then the y-intercept. So if I give you an equation in this form, you should be able to very easily pick out what the slope and y-intercept are. If you see in 3a, it says y equals negative 3x plus 4 Tell me what the slope is and the y-intercept. Well, the slope is the number attached to x, -3. It is not -3x. It is just the number -3. And then the y-intercept is a point on the y-axis. So y-intercept is always going to be written as a point, 0, comma, the y value, and the y value here is 4. Following the same process for the next one, y equals 2/5 x minus 7. We can easily pick out the slope, which is the number attached to the x, 2/5. And the y-intercept is always a point on the y-axis, 0, comma, and then whatever the second number is here, the number by itself, -7. So we basically already talked about the answer then to number 4. Where is the y-intercept located on the graph of a line? This is going to be a point on the y-axis. So you have your coordinates here. Your y-intercept is where your line is going to cross this y-axis. Okay? If we can find a y-intercept, then we can also find the x-intercept. So, which variable did we set to 0 when finding the y-intercept? Well, to write the form for the y-intercept, x is 0, and then we get a value for y because it's on the y-axis. A point on the y-axis has a value of 0 for x. So if I want to find the x-intercept, I'm trying to find the x value when y is 0. So we can then look at these problems and find both the y and x-intercept. Looking at A, it's very easy to pick out the y-intercept because it's in y equals mx plus b form. So just looking at this, I can pick out the y-intercept is -2. So 0, -2. But if I want to find the x-intercept, I'm going to have to do a little bit of work. I have to solve for x when I make y 0. So I'm going to make 0 equal 3x minus 2. And I'm going to solve for x. So that means I need to add 2 to both sides. I have 2 equals 3x, which means to get x by itself, I'm going to divide by 3. So 2/3 equals x. So 2/3, comma 0 is my x-intercept. B is written in what we call standard form. Standard form has the x and y on the left-hand side and the number on the right-hand side, such that the number in front of x has to be positive. That's your other stipulation. So x and y on the left-hand side, number on the right, the number in front of the x must be positive. So we can follow the same process here of using these x and y's, setting them equal to 0 to find the other variable. So starting with y-intercept, we know we want 0, comma y. So x has to be 0. So 2 times 0 plus y has to equal 4. Well, 2 times 0 is 0. So this is just saying y equals 4. So we're going to cross the y-axis at 4. If I want to do my x-intercept, I want to solve for x when y is 0. So 2x plus 0 equals 4. Well, adding 0 doesn't change anything, so I have 2x equals 4. And if I divide by 2, I get x equals 2. So the value is 2, comma 0. And just to show you how that helps us, so we cross the y-axis at 4. We cross the x-axis at 2. And as long as I have 2 points, I can connect the line. So this is the graph of 2x plus y equals 4 by using my x and y intercepts. The next part of this, we are going to find an equation using point slope form and getting it back into either slope intercept or standard form. We're going to find equations given 1 point and a slope, given 2 points, and we're also going to talk about horizontal and vertical line equations. We've already talked about slope intercept form. Y equals mx plus b. M is the slope, b is the y-intercept. Now, if you're given something besides the slope and intercept, say a point and a slope, or 2 points, which you then find the slope, so you now have slope and a point, you're going to have to use what's called point slope form, which over here, y minus y1 equals m times the quantity x minus x1. The colored values are what you fill in. So the pink y1, the m, the slope, and the blue x1, those are the 3 values you're going to fill in. M is the slope, and x1, y1 are going to be the coordinates of the point that you are given. Once we have that, we can always distribute and move things around to get it back into slope-intercept form if the question asks for that. The first 3 examples, we are going to be given a point and a slope. So we are going to first put it in point slope form, and then they want us to translate it back into slope intercept form. So solve back for y. So remember, we're going to start with y minus y1 equals mx minus x1. So find the equation of the line passing through the point, negative 4, 1. So there's your x1 and your y1 with a slope of negative 5/4. So there's my slope. There's my m. So I'm going to fill in what I have. Y minus y1 is 1 equals m is negative 5/4, open parentheses, x minus x1 is negative 4. So the first thing I see, minus a negative, I'm going to turn that to plus. This is my point slope form. In order to get to slope intercept form, I'm going to have to distribute this negative 5/4 out. So y minus 1 is going to stay. I'm going to have negative 5/4 times x, so just negative 5/4 x. And okay, so if I do this, negative 5 times 4 is negative 20. Then divided by 4 is negative 5. Last thing I have to do then is to get y by itself. So I'm going to add 1 to both sides. So y equals negative 5/4 x minus 4 is the slope intercept form of this equation. We'll do the same thing with the next 2. Find the equation through the point 5, 1. So x1, y1 with a slope of 4. So there's my m. Plug in what I got. Y minus y1 is 1 equals m, which is 4, open parentheses, x minus, and x1 is 5. Point slope form is written. So I'm going to distribute so that I can get it into slope intercept form. Y minus 1 equals, that's going to make 4x minus 20. And then to get y by itself, I'm going to add 1 to both sides. So y equals 4x minus 19 is the slope intercept form of this line. Last one, our point is 4, 3. So x1, y1, and our slope is 2. So 2 is our m. Y minus y1 is 3 equals m, which is 2, open parentheses, x minus x1, which is 4. I'm going to distribute that 2 out. So y minus 3 equals 2 times x is 2x minus 2 times 4 is 8. And then to get y by itself, I'm going to add 3. So y equals 2x minus 5 is then the slope-intercept form of that line. What happens now if we have 2 points instead of just a point and a slope? Well, we can find the slope between those 2 points and then follow point-slope formula. It does not matter which point you use. I'm just going to use the one that I have labeled x1 and y1 and go from there. So we're going to do the same process of getting our slope, putting it in point-slope form, and then translating it back to slope-intercept form. We have 2 points, -5, -2, so x1, y1, and 3, -9, x2, y2. So before we can do anything, we have to find the slope. I'm going to take y2, -9, minus y1, -2, all over x2, 3, minus x1, -5. So -9, that's going to end up being plus 2 is -7. 3 minus -5 is going to give me plus 5 or 8. So here's my slope, -7/8. I am then going to go to my point slope form. Y minus y1, which is -2, equals my slope, -7/8 x minus -5. I'm going to turn these into pluses and distribute my -7/8. So y plus 2 equals -7/8 x, and that's going to be 7 times 5, -35/8. Now, the last thing I have to do is get it equal to y. So I need to get rid of this plus 2, so I'm going to subtract 2. The problem is that these are not like terms. So I need to turn -2 over 1 into a number, an equivalent fraction, over 8. So how do I do that? Times top and bottom by 8. So 2 times 8 is going to be -16. Now, how do I know that's true? 16 divided by 8 is 2. So subtracting 2 means I'm actually going to subtract 16/8 so that I can combine these terms together. I have y equals -7/8 x. If I take -35 minus 16, that's -51/8. And that is the final equation for number 4. Number 5, my first point is -4, 6. So x1 and y1. And the second point is 3, -8. So x2 and y2. I'm going to go ahead and find my slope first. And take y2, -8, minus y1, 6, over x2, 3, minus x1, -4. -8 minus 6 is -14. 3 minus negative means plus. 3 plus 4 is 7. Oh, this one reduces nicely to -2. So now I can go to my point slope form. Y minus, well, y1 is 6 equals slope -2, open parentheses, x minus -4. Turn that double negative into a positive so that I can distribute. Y minus 6 equals, distribute here, -2x minus 8. And to get y by itself, I'm going to add 6 to the -8 there. Y equals -2x minus 2. So once you find that slope piece, it's not changing because it's not combining with anything else. Last one, same process. We have 2 points. The first one, -2, -7. So x1 and y1. Second point, 3, 5. x2 and y2. Let's find our slope. y2 is 5 minus y1 is -7. All over x2 is 3 minus x1 is -2. Two negatives make positives. 5 plus 7 is 12. 3 plus 2 is 5, and this one does not reduce. So we'll go to our form. Y minus y1 is negative 7 equals slope 12/5. Open parentheses, x minus x1, negative 2. Turn my double negatives into positives. So y plus 7 equals 12/5 x plus 12 times 2 is 24/5. And what I'm going to need to do is to get y by itself, I need to subtract 7. However, these are not like terms. So I need this to be something over 5. So minus something over 5. Well, if it's negative 7 over 1, and I now need it to be over 5, I'm going to multiply top and bottom by 5. So negative 35/5. Double check. 35 divided by 5 is 7, so it's still a true statement. Minus 7 is the same as minus 35/5. So 12/5 x is going to stay there. That's not going to be a plus anymore. That's going to be a negative. 24 minus 35 is negative 11/5. Next, we're going to talk about standard form. Standard form is in the form where I said the x and y are on the left-hand side, the numbers on the right. The number in front of the x cannot be negative. A and B, so they have to have both an x and a y. Neither of them can be 0. A, B, and C are all whole numbers, so no fractions. And there can be no common factor. An example would be 3x plus 2y equals 12. 3 is a positive. They are all different numbers, and they cannot all be divided by anything. They do not have anything in common. Okay? Something that is not. I cannot have 1/3 x plus y equals 10. That is not going to work because we have to have integers. You cannot have negative 7x plus y equals 14 because there is a negative here. You cannot have 2x plus 4y equals 20 because all of these have a GCF. So just some things to remember. For these examples, we're going to put them into slope-intercept form and then work backwards to standard form. We have a slope of negative 4 and a y-intercept of negative 1. So we can very easily go y equals negative 4x minus 1. Now, to get it into standard form, we're going to move the x term back to the left-hand side. So I'm going to add 4x to both sides, and I get 4x plus y equals negative 1. This is proper form. Positive number here, whole number, whole number, whole number. They're all do not have anything in common. Next up is 8. Find the equation with a slope 1/3, y-intercept negative 1. So we start with y equals 1/3 x and then minus 1. So once we have it here, we're going to move the x term back to the left side. This is a positive 1/3, so I'm going to have to subtract a 1/3 to the other side. This makes negative 1/3 x plus y equals negative 1. We have two things wrong with this. We have a negative in front and a fraction. So what I need to do is I need to get rid of the negative and the divided by 3. And the way I do that is I'm going to times everything by negative 3. So negative 3 times 1/3 is now just 1x. Negative 3 times y is negative 3y. And negative 3 times negative 1 is now 3. It is okay for the y term to be negative. It's just the x term that cannot be negative. Last one. We have a slope of -3 and a y-intercept of 6. So y equals -3x plus 6. Again, we need to move the x term back. So I'm just going to add 3x over here. I have 3x plus y equals 6. And that one is complete. The next types of lines we're going to look at are horizontal lines and vertical lines. A horizontal line will be in the form y equals a number. The way I know I have a horizontal line is if the points I'm given have the same y value. So for example, I have 6, 2, -1, 2. The y values are the same, so the equation is going to be y equals 2. Contrary to that, the vertical line is going to be x equals some number. And if I look at points on this, it may be like 5, 1 and 5, 7. The x term is now the same, so x equals 5. They give us 2 points and want us to determine is it a vertical or horizontal line and to write it. So if I look at 10, the 2 points I have are 6, -9 and -6, -9. So I'm looking for which number stayed the same, and that is the y, or the second term, stayed -9. So this is a horizontal line, y equals -9. Looking at 11, my 2 points are -2, 2 and 5, 2. Which one stayed the same? That would be the second value, or the y value. So in this one, y is equal to 2. In 12, my 2 points are -4, 7 and -4, -1. What stayed the same in this one is the -4, which is the first spot. And the first spot is the x value. So this one is a vertical, x equals -4. Now I know this section is a little bit longer, but this is the last part we're going to work with, which is parallel and perpendicular lines. So we're going to determine, are our lines parallel or perpendicular, and how do we write parallel and perpendicular lines to a given line. So before we can determine what we have, we need to talk about what they look like. Perpendicular lines are going to be opposite reciprocal slopes. So the example I give you here, do note that the equations here do not match what the picture is here. This is just a separate example. 2x plus 5 and y equals -1/2 x minus 4. So if I look at the slopes, 2 and -1/2 are called opposite reciprocals. One is positive, one is negative, and they are reciprocals of each other. 2/1, 1/2. They will form a right angle if you were to graph them on your graph paper or a calculator. Slopes that are not opposite reciprocals and are not the same, which is what we're going to talk about over here in parallel, are going to be in neithers. So let's talk about parallel really quick and then come back to neither. Parallel lines will have the exact same slope. So y equals 1/3 x plus 10, y equals 1/3 x minus 5. They will go at the same rate. This creates a graph like train tracks that will never intersect. So that means neither means you have something else. I don't have opposite reciprocals, and they're not the same. They're just different. So for example, a slope of 6 and a slope of 1, they're going to intersect in some other way that is not a right angle. We are given 2 lines or 2 equations. We need to determine if they're parallel, perpendicular, or neither. So in order to do that, we have to make sure they're both in y equals mx plus b form so we can look at their slopes. So this first one, y equals 2x plus 5, my slope is 2. So this guy I need to solve because it's not in the right form. 2y minus 4x equals 12. I need to turn it into y equals form. First thing I'm going to do is add 4x to the other side. I have 2y equals 12 plus 4x, or you can write it as 4x plus 12. It doesn't matter. In order to get y by itself, I'm going to divide everything by 2. So y equals 12 divided by 2 is 6, and 4 divided by 2 is 2x. So we can see here, 2 is attached to the x here, 2 is attached to the x here. They are the same slopes, so they are parallel. In B, our first one is not solved. 3x minus y equals 8. I'm going to need to solve that for y. So I first need to get rid of that 3x. I'm going to subtract 3x from both sides. Gives me negative y equals 8 minus 3x. I cannot stop at negative y, so I'm going to divide everything through by negative 1 and get y equals, that's going to make negative 8 and then plus 3x. So looking at our second equation here, we have y equals 5x, so the slope is 5. And this one, 3x, the slope is 3. They are not the same, and they are not opposite reciprocals, so we have a neither relationship here. Working with C, we again have to solve one of these for y. That's going to be the first one. I'm going to pull it down here. X plus 3y equals 12. To get y by itself, I first need to move the x. So I'm going to subtract x from both sides. 3y equals 12 minus x. And to get y by itself, I need to divide by 3. That tells me y equals, well, 12 divided by 3 is 4, minus, and there's an invisible 1 here, so 1/3 x. So looking for the x term, I have negative 1/3. And looking for the x term here, I have 3x. So negative 1/3 and 3 are opposite reciprocals. So this is perpendicular. We just worked through this whole process, which means 2 should be really easy to answer. Which term in the equation determines whether two lines are parallel or perpendicular? And that is the slope, or the m, which is attached to the x. The very last thing we are going to do is write parallel and perpendicular equations. Question 3 says to write the equation of the line parallel to y equals negative 5x plus 4 passing through the point negative 2, negative 7. As long as we have our parallel, we have our slope. So our slope is negative 5, and our point, our x1, y1, are negative 2, negative 7. So we can go right to our equation, y minus y1, negative 7, equals slope, negative 5, open parentheses, x minus x1 is negative 2. Remember that two negatives make a positive, and then we're going to distribute the right side. So y plus 7 equals negative 5x minus 10. And our last step is to get y by itself. So I need to get rid of that plus 7. I'm going to subtract 7. Y equals negative 5x minus 17. And I know they're parallel because both slopes are negative 5. Looking at number 4, we see that our given equation is 3x minus 2y equals 5. Looking at this, we can't pick out our slope yet because it's not solved for y. Let's take that 3x minus 2y equals 5 and solve it for y. 3x minus 2y equals 5. So the first thing I need to do is move the x term. I will do that with subtraction. Negative 2y equals 5 minus 3x. To get y by itself, I'm going to divide by negative 2. And we get y equals 5 over negative 2 Let's see, 2 negatives can make positive 3 over 2x. So our slope that we're going to take with us is 3 halves. And our point, our x1, y1, is negative 1, 3. We can go to our form, y minus y1, so 3 equals 3 halves x minus x1, negative 1. 2 negatives makes a positive, so then I'm going to distribute it in. Y minus 3 equals 3 halves x plus 3 halves. To get y by itself, I need to add 3 to both sides. Now, I can't add 3 to 3 halves because they're not the same. So if I think about that, this is currently 3 over 1. I need to have it over 2. So I need to multiply the top by 2 as well. So 6 halves. So I need to add 6 halves to 3 halves. That will give me y equals 3 halves x. And let's see, 3 halves plus 6 halves is 9 halves. 2 parallel lines have blank slope with different y-intercepts. Well, 2 parallel lines must have the same slope, and their y-intercepts are going to be different. Now we're going to do the same process, but with perpendicular. We want to write the equation of the line perpendicular to y equals 1/3 x plus 8, going through the point negative 1, 3. Well, we know our x1 and our y1, but we need to do a little bit of work with our slope. The given slope is 1/3, but I want perpendicular slope. For perpendicular slope, I need to flip the fraction over, so 3 over 1, and then change the sign. So it's positive, it's now going to be negative, so my perpendicular slope is negative 3. And then I can follow the process like I did before. Y minus y1, which is 3, equals slope, negative 3, open parentheses, x minus the x1 is negative 1. So I will add those because 2 negatives makes a positive. I have y minus 3 equals, distribute this in, negative 3x, that's a plus, so negative 3 times 1 it makes negative 3. And then I need to solve for y, so add 3 to both sides, and I get y equals negative 3x, and that piece cancels out, so it's just y equals negative 3x. Number 7, write the equation of the line perpendicular to x plus 7y equals 13, passing through our point 5, negative 9. There's our x1 and y1. We cannot pick out our slope yet. X plus 7y equals 13. It is not in y equals form. So I must first get x to the other side. I'm going to subtract it. 7y equals 13 minus x. And now I need to get y by itself, so I need to divide by this 7. Y equals 13 sevenths minus 1/7 x. This is my given slope, negative 1/7. I want perpendicular slope, so I'm going to flip negative 1/7 into 7 over 1 and change the sign. So this one's negative. My new slope is now positive, so my slope is 7. 7 over 1 is 7. Go to my equation. Y minus y1, negative 9, equals slope, which is 7, open parentheses, x minus x1, which is 5. That becomes pluses, so y plus 9 equals, distribute on this side, 7x minus 35. And to get y by itself, get rid of that plus 9 by subtracting 9. So y equals 7x minus 44. That is the end of that section, so you feel free to go ahead and work on the homework.